All right. Today's webinar is being recorded and will be uploaded on our YouTube channel, which you can find by either searching SPEER on YouTube, or you can go to our website at eepartnership.org. And under our news section, you'll find our resources page. Once you're on the resources page, you'll find a link to our channel. Within 72 hours of today's presentation, you will receive a course evaluation email from Kathy Lawrence. Please complete the survey and send it back to her to receive your full course evaluation certificate. It will contain your course ID number you'll need when you're using it to report your CEUs to ICC. Lastly, the chat feature is open. Please use that to report any technical difficulties you might have or you're experiencing during the presentation. And the Q&A feature is also open. Please use that to post any questions you might have, and we'll answer those in real time. So just a little bit of housekeeping real quick. Those that don't know who SPEER is one of 6 RIOs, Regional Energy Efficiency Organization. We are member-based. We're nonprofit. SPEER actually covers Texas and Oklahoma. We're 50 members, ranging from a wide cross-section of energy efficiency industries, from product manufacturers to any other organization that actually pushes for adoption of the code. And also, we're focused on outreach of education and collaboration of clean energy. So what I do on a daily basis is I do webinars, in-field training, in-person training, also do IECC test prep training for any of those looking to do the IECC testing and be certified. The price is always right because it's free. I can help with any questions regarding the energy code and ASHRAE 90.1. I can help with any questions from plan reviewers to building officials to third-party energy inspectors. I'll be happy to help you in any way that I can. We can also assist we have been assisting several cities with the adoption of 2021 and basically helping them with navigating the additional amendments that a lot of cities are adopting to lessen the impact of adoption when it comes to moving from like 15 to 21 and having builders to be able to have a lesser impact of that. At the end of this presentation, my contact information will be there, so please feel free to reach out with me if any questions. You can also feel free to share my contact information with anyone that you think needs me to help them answer questions. And then we can get started with this. So let's get started with our video today. Hold on one second and I'll share that screen. All right, so you should be seeing the video that's pulled up there. There is some background music I've added to this. If it's too loud, please let me know in the chat. I'll get that turned down, but it should be quiet enough. It's just basically there to fill the dead air space. So we'll get started with this. We've got 2 inspections that we're walking through today. Both are pre-drywall. So this is our first inspection. If you were with us during the polysil inspections, you'll probably recognize these houses. I've used both of these 2 houses we're doing today as my training and doing some recording as I'm basically here to watch them go through the stages. So what I do normally, once you get to a house, you do a 360 real quick and say, is it ready for inspection? This looks to be ready. It's fully insulated. Usually start on one side of the house or the other, and then you just go counterclockwise or clockwise around the home. Just verifying what kind of insulation did they use. They got bad insulation. I'll start recording their R values on all these components. These are R13 walls. As you can see, it was T-ply and zip board on the outside for the air barrier. A lot of compressions here. It looks like it's fully filled. There's not really a lot of gaps or voids. I'll zoom in on a compression here real quick, but that's the kind of stuff we look at when we say, how do you grade insulation? How well was it installed? This is a compression here. Doesn't have to happen. It just got pushed with a stick or a hand, or the veins that you see there usually means that it's too wide for that cavity. For some reason, it's collapsing itself in the middle. That's usually not a good sign. These nail guards are a dead giveaway for wire being behind it, so making sure that it's splitting around the wires. You could do that one of 2 ways. You could do like they did here and actually tear it in 2, or you could split it horizontally and put a little on the top and a little on the bottom and sandwich that wire in between. Either way, you're trying to reduce gaps behind there. Looking at electrical boxes, It's not really cut the greatest, and it looks like they stuffed a little bit on the side there that was a piece of trash, but you know, is it insulated behind there? I see a blob of polyseal, so I'm going to inspect that. There is polyseal there. They sealed it from where the wire's coming in, but as I put my hand behind the box, there's no insulation back there, and there's no polyseal back there. So that's, again, just another gap, missing insulation. Air sealing isn't done 100%. No advanced framing. That's a outward facing V with a dead space in the middle, no insulation. They put polyseal right there, but it doesn't really do anything. It's going to get worn out with a screwdriver before they sheetrock. No evidence of a top plate gasket at all. There was gaps missing kind of where that bat was on the top plate. Again, nail guards are a dead giveaway. There's something behind there. So I usually check 2 cavities per exterior wall, just to verify that the person that was doing this room probably did a good job of cutting around all of them. Still a lot of compressions. There's a pipe and/or a gas line that's there. As you can see, there's a lot of gapping in the front. They could have put some kind of insulation there, but you know, it's metal. It's going to transfer heat pretty well. So we'll need to double check, is it actually insulated in the back? And it kind of was, but as you can see, I didn't have to pull very hard and there's a gap there. So not really insulated fully behind it, no insulation in the front. Bulging like that usually means that there's something behind there. And the ground wire was in that cavity, so that's kind of why it looks like it was probably cut a little, not cut short enough in the width, so it bulged it out. No ladder blocking here. Again, that much polyseal in the corner like that, not necessary. It doesn't do anything, doesn't help at all. It's just going to get removed with a screwdriver. Should have insulation in that T-wall intersection there in that dead space, but not fully filling that with polyseal. Usually I check the first few and then eventually I'll just kind of stop looking, because if you've already checked 4 or 5 and they're not done, probably pretty sure and pretty safe that none of it's done. No interior air barrier behind the tub. That insulation is poorly installed. It's hard to do it once the tub's already installed. They kind of shove it in there with a stick or try to reach in there with their hand. A lot of times it doesn't even get pushed all the way to the exterior wall. As you can see in that second cavity there, it's leaning against the tub, not on the exterior wall. So not very well insulated, and no interior air barrier. Again, probably the last time I'll check with this house on advanced framing, which there is actually there's a question in the chat about advanced framing. So just to explain that real quick, is we saw earlier the outward facing V is a dead space with no insulation. If you look up advanced framing on Google, you'll see pictures and of assemblies and framing of how you do corners and how you do T-wall intersections. On the T-wall, you could turn the stud. One of them could be turned the opposite direction, and you can get insulation to the back. Code wants you to have at least an R6 in the corners, but having an external facing V, there's no insulation there. But turning one stud allows you to get at least an R6 or a compressed 13 in there, still resulting in 6 or more. This T-wall intersection you see here, you could do the same thing as you do a side corner or an outer corner, is turn one of the studs the other direction, and it allows you to fully get insulation all the way to the back and reduce thermal bridging or a dead space with no insulation. Or you could do ladder blocking, which is basically just like it says, you're putting a ladder up with frame members, but they're turned on their short end to allow for insulation to get behind it. So what I'll probably do, since we have questions about that, is I'll probably end up doing a video just over advanced framing techniques. Code doesn't necessarily state that it has to have advanced framing techniques, but again, here we got bulging means that there's a gap behind there, leaving chances of convective looping because you've got an empty gap that's heating up and cooling down to have convective looping through there, which you don't want. But back to what I was saying a second ago, is code doesn't specifically specify. It says reduce thermal bridging. If you can frame differently to reduce thermal bridging, why would you not? That means ladder blocking. That means 2 stud corners. That means insulated headers. those kind of things. But if they're not being done, you're just adding to, speaking of insulated headers, no insulated headers here. With this, as you can see, it's a sandwiched header. It's got OSB stuck in the middle. I can understand if they're doing this for structural integrity and to hold the weight of second floors or a support beam above it. I get it. Sometimes it may have to have that structural integrity, or it may be a solid piece of 4x4 or a 6x6 solid piece of engineered lumber, because it has to have weight distribution. And I get it. That means you're exempt from the code from having to insulate it. However, with this, there's no reason to have OSB. You could leave it empty. Air gap is an insulated, does have an insulated R value property, but you could easily put R3 board in there. That's a 1/2 inch thick. You just sandwich it in between, and you've got an insulated header. Again, you're cutting down thermal bridging is what you're doing. The fewer you can have of thermal bridging, the more reduction of heat load coming in, which means the house will stay more comfortable. Energy Star requires it. If it's not advanced framing in the house and you're trying to get Energy Star certified, you won't get Energy Star certified because there's no advanced framing being used. Again, there's a huge wet wall here, a plumbing wall with a 2x6, and that whole channel behind that key wall is not insulated. It's just a devoid of insulation. Huge gap. That polyseal is going to be torn out. Making sure it's insulated. Oh, then we actually see it's not insulated, but there's a huge opening to the outside. It means probably the plumber came in to do something. They're going to probably fix that later. Insulated on the top of the tub. Put my hand behind this block, reach down. There's another blocking. Turn the other direction. I can't push my hand all the way down. Can't verify there's insulation behind the tub. However, there is an opening at the end that you could see. But if it was already closed off on both sides, there'd be no way to actually verify that. No interior air barrier, as we said earlier, which is required by code. It's insulated better, but still no interior air barrier. As you can see, the veining that's happening in that insulation means it wasn't cut to fit. It was a little bit too big, but they made it work by just crushing it in there. When you compress insulation, you lower its R value. So polysealed on top, nothing behind it, no insulation, no air sealing, just polyseal where the wire comes in. Met half the intent, not all the intent of what code wanted to be done. Lots of compressions. You can see the side profiles of a lot of that stud. I get it. They install it quickly. It's installed by the piece. They're friction fitting it. The framing members may not be fully perfect, but you know, it could be done a little bit better. No insulated header here. A little bit of a gap. Still some more compressions. I mean, overall, I'd probably say grade 2 on this house. I mean, you've got quite a few compressions, but it's not enough to give it a fail. It is fully insulated. No, not a lot of gaps, not a lot of voids. But the compressions actually drop it down in how well it was installed. Verifying the vaults. Now this vault here that I'm looking at, it's got an attic exposed side to it, which means it could have had an R38 or R49 bat, whatever is required in this area, which ironically is required to be R38 in this area. And so it should have had that. Hopefully they'll blow attic insulation over the top to make up for the difference, but it could have easily just had R38 instead of R30. That's a pretty steep slope there, so keeping insulation on top of it without it rolling down or piling up at the bottom is probably not likely going to happen. R22 in the vaults that do not have attic access above, which is a cathedral type vault ceiling. They did some pre-batting around that HVAC duct. That's great. Keeps the insulator from having to get back there and trying to blow that full of insulation. But it's only 22. Baffles extend beyond. They actually will be extending beyond the blown attic insulation in the depth. No interior air barrier again on the inside of this fireplace. No netting either. It's nothing to hold it in place. Even all the way underneath it. There's no internal air barrier. They did seal this fireplace chase at the top, so they've made the interior of that fireplace part of the envelope. They did seal this with fire caulk. A lot of times builders tell us the cities say that you can't do that, but obviously this city is okay with it because there's fire caulk. I recommend that. If you can do it, that's a big air draft that can be stopped easily with fire caulk. That fire caulk is, you know, fire rated, it's temperature rated, and it will expand and contract with the metal. Looking at service decking over the kitchen area, just verifying it is R19. I looked at the end of it to determine the depth because there were no R value markings on the underside. They flipped it the other way. They've pre-batted over some of the top plate of the garage wall. So I'm starting back over where I left off. I just quickly went to the center to actually look at the top of that. Again, R30 bats in the vaults that have plenty of attic access above. I'm not sure why they're only using 30s. Should be 38 or 49 depending on what climate zone you're in, or even 60 at times when you go further up north. Exterior box that's facing inwards, got polysil on it. That's great. Just trying to verify, is it cut around the wires? Yep, cut around the wires. Let's say usually just check a couple of them. One more look back at the fireplace. Now I'm going to step out here and look, and then I'll pause the video to talk about this. But looking at the top plate, making sure the top plate is covered fully with insulation, using these bats, it's not. The porch patio or the porch attic over the patio, it will not be insulated. It won't have blown attic insulation over it. There won't be anything covering over the top plates. I hope they blow insulation over it, but being that it's a vault and it's on a slant, and if you put attic insulation there, it's liable to just roll off or blow off into the attic empty space over the porch. So this should, in 2024 IECC, it's going to require for end-damming to happen, which is either using bats or netting or a solid material like OSB, and you put up a dam, and that way you can get R30 completely, or whatever R value is required, over the top plate, completely covering the top plate, not allowing for top plates to be exposed to the attic air. When they're exposed to the attic air, it increases thermal transfer of heat. Again, just kind of haphazardly put up there. There's a lot of missing pieces over some of those top plates. In that corner, there's nothing really there. There's a framing member in the way. I get it. Can't always get it accurate. All these vaults still R30. I just keep double checking to make sure. Was I just seeing a few 30s and the rest 38s? But this is all R30. A couple of 22s stuck in there, but my hope is they're going to blow attic insulation over it. Completely over the top where you see it's empty, and down the sides. Gaskets on can lights are still there. Polysil around electrical boxes still there. So just verifying that. Again, I may not have been the person doing the polysil inspection, so I need to also verify those things for my benefit to know that it was done. Small gaps, less than 20 or 16 inch on center, actually used with pieces that are just kind of crushed in there. I'll reiterate again, if you crush insulation, you lower its R value. So every time they think it looks like it's insulated, but it's just crushed, it's really not as fully insulated as you think. Lots of compression still. They pre-batted the corners, which is good. That eliminates the attic insulation guy that's blowing the attic insulation from trying to get in those back corners. There may not be enough spacing there to add that much insulation. Just notice that a baffle is missing. So there's going to be some wind washing happening right there in that corner unless it gets installed. It wasn't on the ground, so it didn't just blow out. I think they just forgot to do it. Now we're in the main bedroom here, looking at lots of compressions. But again, I'll just check behind some of this just to check, make sure the wires are cut. And well, they missed one. So not perfect. So what I'll usually do is keep checking to see how many were missed until I find one that was done. So we'll go to the next one, and still not done. So I'll do one more, and it is done. So not bad. You got 2 missing out of what we've so far inspected as the most of the house, so I'm okay with that. This is the mechanical ventilation or fresh air chase. It needs to have an internal air barrier. It does not. As you can see, I'll stop and pause it here, though. They did block it and seal it from the top. They blocked and sealed it from the bottom, which means they've built a chase that's part of the conditioned space. It's not outside the envelope. If you left it open at the top, then it's an extension of the attic, and then you have to do different things to it to make sure that it's air sealed and insulated properly. When this first started, what they used to do is leave it open at the top and just fill that full of attic insulation. They would just blow it full. Not really the best way to do it. So doing it this way, in my opinion, is the best way, but you need to include an interior air barrier. The duct's installed better than what it could be. That chase is big enough to hold that duct and not crush it. Insulation underneath the tub, no interior air barrier. And as you can see here, poorly installed insulation. I mean, I get it. The tub's already there. You're the installer of the insulation. You're trying to get insulation back there. You either push too hard because you're trying to reach it with your hand and it crushes it, or you just kind of split things in two and you just shove what you can there to make it look like it's insulated, but it's not really insulated. If you fully fill it with trash of the insulation, cut pieces, instead of carrying it off site, just pack it full of insulation behind there, gives better insulation value for that tub, and you don't have to use an air barrier. No top plate gasket here. Hopefully the sheetrock guys will do it, but more than likely this house is probably not going to get a top plate gasket. Still goes back to, I'm not really sure how some of these things will pass blower door. Just checking it from the other side. Still no internal air barrier there. R13 bats again, looking for any kind of wiring just to make sure it's split. My hunch was there was something there because of where the plugs were located. No nail guards, which should be. This is the garage wall. They've pre-batted over the top of the top plate of the garage wall, which is good. That's end damming, but it's only R30. It's not 38. But at least the top plate's covered. And when they blow attic insulation, they don't have to try to blow it to the edge and hope that it all stays. They're going to pre-bat it. That way it's always covered. Because as you know with garages, if you have a pull down stairs, the minute you pull that down, all the insulation blows off. R19 wall, it's a 2x6 wall in the garage. So just recording that, looking at the other side of the service deck. R30 under the service deck. If they could get that, then they will. That's probably next to a service deck, not actually the service deck. It's probably a piece that was left over. This is the plumbing wall and the utility. It says R19 in a lot of them. It's a 2x6, but as you can see, there's a lot of insulation, depth of insulation missing. So perhaps they used 13 in some of those cavities. Yeah, no decking above that I can see, so R30 it is. They pre-batted at the top, covering that top plate over the garage wall. That's a great way of doing it. Glad to see that they're at least doing that. As you can see here, though, bat's not fully covering. You can see a lot of gaps there. See a lot of daylight. It's either lifted up at the end or the bat was cut very short, which you're trying to pre-bat it to cover the top plate, but you cut it too short and you don't actually cover the top plate. So one of the builders that I used to do inspections for, that would have been a red tag for them because they said, I want that done. They see the benefit of it. They want it covered. Some tight fitting gaps there. Just looking at the exterior wall, the front side of the house. We've come full circle now. We're back to the front door. Unusual looking header here. It's actually turned on its side. Probably due to spacing. I get it. There's probably not enough room there, so they decided to flip the 2x4s on the side. But again, you can clearly now see OSB trapped in there instead of using an R3 board to insulate that header. Another header here done sandwich style 2x6. Still not insulated. Again, insulated headers just basically need to be an R3 board that are sandwiched in there instead of OSB. Checking this is the garage wall underneath the water heater deck. It is not blocked. Well, it is blocked, but it's not sealed. Why they polyseal all across the top of those boards, I don't know. It's not really necessary. Maybe they do it so water does not go down inside of it. Garage wall from the other side. Still some gaps there. Then I went back in real quick just to verify bath fans and realized that one of them actually had a duct that was crushed. I guess the light showed up later, or the installer of the bath fan duct actually had to get around that light, so he did the best that he could to crush it to get it installed. Not good if you have to test the bath fan for CFM requirement. Second inspection here, you guys will probably recognize this house. They were actively insulating this when I got there, so I give them the caveat of they're not finished. I get it. There'll be things that I call out that may or may not get fixed. But the first thing I noticed with the floor over garage was missing hangers. So it needs to be in permanent contact with the floor above being conditioned. It's not. It's hanging down on wires and piping. Right in the middle here you see not cut to fit. Gives a deep vein here that actually allows for more thermal bridging and heat transfer into that floor. You probably could see that with an IR camera from the top once the house is being conditioned. Not in contact with the floor above. Again, they just give them the benefit of the doubt. They are probably going to come back and put hangers in there. If they don't, then they're not installing this correctly. Still insulation hanging down. I noticed over here where the flue pipes are, there's missing insulation in that area. Some cities will actually tell you that you can't put insulation in contact with the flue pipe. Others don't really say anything about it. My first assumption is maybe this city requires you to keep it away from it. But as you see later in this video, you'll see that there is insulation in contact with the flue pipe. So I don't think that's a city requirement. Looking underneath there, it is blocked with T-ply. I didn't see any polyseal, but they did block it. The band joists are blocked. We looked at that at polyseal. It actually was done correctly. And moving into the house, I don't take my usual pattern of spinning 180 and keep going from counterclockwise. They weren't finished insulating, but missing underneath the service deck. They may or may not actually get that installed in time before sheetrock actually gets installed. Verifying the service decking. I don't see R values posted on it, so I'm looking at the end of it to determine thickness and R value. That would be an R19. It's in contact, will be in contact with most of the sheetrock above. Some of it's pushed a little too high. You can see the side profile of the studs or the joists that are running through there. And then we head upstairs. We'll revisit those stairs in a minute. I was just letting those guys try to finish up what they could downstairs. First thing I notice here is a chase, a duct chase. No air barrier on the inside. No insulate, no, not even netting or anything. They blocked and sealed at the top, as it should be. Trying to do my counterclockwise at the second floor. They're not quite finished here either. A lot of compression still happening. No top plate gaskets. We've noticed this in a previous video, but there's an open knee wall. On the other side of that will be in conditioned space, so it should be blocked in the back and insulated, but neither has happened. Service deck is yet to be insulated. We'll talk about this little wall in a minute from the other side, but that is also an exposed attic knee wall. The vaults aren't batted there yet. He'll get that probably a little bit later. Looking at compressions that are there. I just wanted to show a lot of stuff on this house that aren't getting done, but it's not a full inspection that I was doing for this just because they weren't finished insulating. This is the back side of that little knee wall. It's interior that I'm looking at on this side, so it's an open knee wall on the back. Should be blocked and sealed from the back. It's short enough you can fully blow insulation over it, and as long as you blow insulation all around it, Energy Star says you're okay with not having a block. Code doesn't give you that option, so it really should be blocked and sealed from the back. What you're doing is upholding the integrity of the R13 in the wall to make sure that that R value stays consistent. No advanced framing here. There's no ladder blocking. Lots of compressions that are still here. You can still see the profile of those side studs. Compressions there, so I decided to check that because it looks like there was compressions. Lots of poly at the top where the wire came in, but no insulation or polyfill behind it. They did split around the wires. So done really well there. This is the second floor attic wall. So lots of compressions, but still fully insulated. Looking at a duct chase. No interior air barrier on that. No netting, no interior air barrier. Just insulation only, friction fitted and trying to be held in place. They've made this little chase here part of the envelope, and it's now in conditioned space, even though they blocked it from the top, and they probably won't insulate the top of it, which means it kind of is going to get heated up, which kind of tells me with this, you don't have to block and seal and insulate behind this tub because it's part of the conditioned space, because the chase is being considered part of the conditioned space. But if they're not going to blow insulation over the top of it, it becomes not really a conditioned area. It may overheat over time and get a lot of heat to that bathroom. One of those things that you probably would need to verify at final when you go up in the attic to verify attic blown insulation is just take a quick peek over there and see, did they actually blow insulation over the top of that OSB? If they didn't, that's a misalignment of the thermal envelope. R30 bats, that one's kind of fluffed there. It looks a little thicker than it is. It looks like it might be a 38, but if you look at the R value, you can clearly see that it's R30. Making our way around the second floor, you can still see him actively doing insulation. Checking this bay window that sticks out over ambient. They did insulate the seat area, but looking up, they have yet to insulate the top. He'll probably get it as he comes around with those stilts. Looking at vaults again, there's attic access above it. I mean, you can, hopefully they'll blow attic insulation over the top, and if they don't, then they're not insulating it to its fullest thickness that it should be. So this is the media wall that we've actually looked at before in previous videos. No interior air barrier in here at all. So no blockage from the attic at the top. So it's open from the attic at the top. No blocking above that false wall that's in the front. This is me. This house was actually already sheetrocked when I walked it again. This is me looking into that wall through an opening for a media outlet, shining my light in there and shining my camera in there. You could see that it's netted, but that's not an air barrier. So insulation is not, it does not have an interior air barrier. It's a misalignment of the insulation and the interior air barrier because the sheetrock is on the front wall, insulation is on the back wall. That's a misalignment of the insulation and air barrier. The next one's actually at the top. So as you can see, it is still open to the attic. So with that Smurf tube and the opening media boxes on the wall, I don't really know how this is going to pass blower door. I'm not the energy inspector. I'm not doing the blower door test. I really don't know. This is the same chase or same wall that's there. It's now you can see insulation around those flue pipes, but still wide open to the attic. There's nothing going to stop the air from transferring down that wall. Just verifying vaults again, making sure that they're A, they're insulated, and B, that they're at least R30, which they are here. And then looking at the attic side wall of the media room, just making sure, well, is there splitting around wiring? Trying to find where, yep, it's there. There's no nail guards there for some reason. It was only a 2x4. I mean, if they're back far enough, they don't really have to have a nail guard. Depends on the depth of it. Lots of compression still. That still bothers me about the media wall. I went downstairs. They finished some more of the walls, so just actually did a quick spin on that. They didn't finish the top. There's no insulation in this chase. They probably didn't finish it, but that chase is a lot smaller than the one we saw a second ago. A lot smaller. It is basically folded that duct and crushed it at the time of where it's coming in from the outside. It's in 2021 IECC area. It will have to be tested. So this is the first point of probably it failing, is having it crushed at the inlet. There's not going to be really a way to fix that. They really should not make those chases that small, but that's one of those things where the contractor that does the framing doesn't understand what the HVAC is installed that for. He was just told to build a chase and make it as small as you can, and that's what they did. Looking under here, we see that there was a hole that was there as well. It was filled, it was poly-sealed, and now I'm here at sheetrock, and I still have access to it because the tub wasn't installed, and you can see the insulation's been removed. It's fully sealed, and maybe someone did that for an inspection to make sure, but they didn't put the insulation back. Chances of it getting put back is probably slim to none. This is underneath the tub. It's still standing up there in the bathroom. It's not installed yet, but they've got the wood framing there, and now we're at sheetrock, and there's still no internal air barrier. It's just sitting in there. So again, you could fully fill that with insulation, and you won't have to have an air barrier on the inside, but if you don't, it should have an air barrier on the interior. Just verifying this wall again, you can see lots of compressions, splitting around wiring is done correctly. Check 2 cavities there to make sure it was done. Missing insulation above the windows. They're not done with the house yet. Not pushed all the way in at the top because they're not done. Checking the fireplace again. And you see this is a different house, different fireplace chase, but no interior air barrier. I didn't get a full shot of that, but they did not seal it with fire caulk. I'm not sure why. Maybe they'll be back later to do it, but it was not sealed with fire caulk. Interior steps against the garage wall. There is supposed to be air barriers underneath here, and there is no internal air barrier. So here's with it being the house already sheetrocked. I still had access to the underneath the stairs. I still can see that there is not an interior air barrier, and so that's not a good thing. And as you move up the staircase, you can see clearly there's gaps in those stairs, and you can see the back wall behind it. And so if that's going to be carpeted, that's big openings for air to be moving through that garage wall that doesn't have an interior air barrier on it. And so it's again, I don't know how this house will pass blower door. I won't be the one doing the test, but I'm afraid that the final form that has to be turned into the city with the results may have to be doctored to show a pass. No internal air barrier here. I was able to show, or able to look between the stairs, the gap in the stairs. I wasn't able to get a picture of that, but I could still confirm that there was not an air barrier back there after sheetrock. So a lot of those openings on the stairs. Subfloor still open to under the stairs. So having those stairs there with the gaps between each one, if there's carpet on there, that's where a lot of the air is going to come from, is that subfloor opening right here. It should be blocked and sealed or fully filled with poly to seal that off, and it's not. So it's probably going to be bleeding into that floor. If it's wood that's installed over the stairs, you're lowering some of that air infiltration, but you're still not fixing the problem. Just another shot back at underneath the stairs. No interior. This is a second bathroom shower seat. If you look at it again, top left, poorly insulated. I mean, I could barely even see that there is any insulation in the last one. They probably just tore some of it in half and just kind of stuck it back there. So upon first glance, looks like it's insulated, but it's not fully filled with insulation, and there is no internal air barrier. And they stopped the polyseal because they probably did it after it was framed and didn't fully polyseal around those base plates. There's a gasket showing, so that's their second line of defense. So that was the pre-drywall walk with that. Let me share my other screen real quick. If you have any other questions, please put it in the chat. Right now, do still have another question with CEUs if you were joining late. So the CEUs, 72 hours after this presentation, you will get an email from Kathy Lawrence with a survey. Please complete that survey, and once you send it back to her, that she'll give you a course completion certificate, which will have the course ID number that you'll need when reporting CEUs to ICC. Next webinars we'll have is April 20th at 11 a.m. It's again part of this same series, energy inspection, but we're doing mechanical ventilation testing. So what we'll do is I'll be walking with a third party looking at different products that they make for mechanical ventilation to now meet code requirements. And it's also required to be tested. So we'll be testing some of those as well. I'll be showing you some of the products and the tools that they use to do mechanical ventilation testing and how they determined the best way and the best method to test it. And then on May 11th, please pay attention to the time. It's earlier than normal. It's at 9:30. So we'll have an update on stucco of its best practices and what's been seen out there. So Jeff Adams with Adams Home Inspection. He's actually been working with Jason for a long time, working with seeing what is being done out there in the field, what shouldn't be done out there in the field. So he's going to give us an update and a run through on what he's seen on stucco and kind of the caveats of things that really need to be addressed when seeing stucco. It's being more and more common in today's construction. Again, thanks for joining us today. My contact information is here. Please feel free to call me anytime, email me, text me. Please feel free to share my information with anybody that you think that needs to have some questions answered, or if I can walk them through some requirements for the code. So again, thank you again for joining us today, and we'll see you all on the next video. Appreciate it.